This last section is called Venn diagrams and two-way tables. So we can use Venn diagrams and two-way tables. They're a way of showing the sample space in multi-step events. Let me show you what I mean. So it says here, a two-way table, that's our first blank. A two-way table lists the number of outcomes or people in different categories, with the final row and column being the total of all the other entries in that row or column. That was very wordy. But what it means, you can see a table right there. We have a table of people who like math. So we have people who like math, and it would go in here. And we have the people who do not like math. We are wanting to compare that with the people who like English and do not like English. So I'm going to make up some numbers to put in here. If I put, let's say, oh, there should be lots of people, right? 8 people. That 8 people like math and they like English. So they're going to be both. They like math and they like English, both of them. However, you can put this in. This is just an example. I'm just making up this data though. If I put a number underneath, let's put a 5 down there. They are people who like math but do not like English. Altogether, if I add those numbers together, 8 plus 5 makes 13, which means there are 13 people altogether who like math. Some of them like English as well, and some of them don't. Let's look at the second column. Let's go people who do not like math, but they like English. Okay, there wouldn't be very many people for that column. So let's put like 3 in there. We'll have 3 in there. That's you, is it? Okay. So do not like math, but like English. There's 3 people that go in there. This next box is people who do not like either. So let's put a 1 in there. Okay? Someone that doesn't like math and they don't like English. All together, guys, that's not appropriate. Stop yelling out, please. Altogether, that is a total of 4 people who are in the don't like math column. If I go horizontally now, I want to focus more on the English side of things. There was 8 people who liked English here, 3 people who liked English here. That's a total of 11 people that like English. Okay, the do not like English. I have 5 plus 1 makes 6. There are 6 people who do not like English. Now that last final little box, you can work it out in 2 ways, and it should be the same either way. I can go 13 plus 4, which equals 17, or you could do it vertically. 11 plus 6 also equals 17. Either way you do it, you should always get the same number there. If you get something different, like if you're checking vertically and horizontally and you get something different, it means you probably put one of the numbers in the table wrong. Okay, now we can take that kind of table, which is a 2-way table, and by the way, in these tables, it's always like something disliked, like dislike. It's always like the opposites in there, okay? We can take those results and we can put them into a Venn diagram. Now, this is a diagram that was created by someone with the last name Venn. That's why it's called a Venn diagram. It is a pictorial representation, meaning a picture, of a 2-way table. So it actually shows pretty much the same stuff as that 2-way table does. Okay, so to put the results in there, I'm going to have one of these circles being the people who like math, and the other one is going to be for the English. And I'm going to take the numbers out of my table to fill this in. Where the two circles overlap means that that is the people who like both subjects. From my table, there was 8 people who liked both math and English. So there is 8 people in here for the both section. The number that goes in here, these are the people who just like math, but they're not the ones that like English as well, just the math. So like the math but not the English is the 5. Just as a bit of a check, remember that there was 13 people who like math, and in that whole circle, that whole math circle, it does add up to 13. Works, okay? So let's try the English circle. The English circle, we already have 8 for the overlapping. We just want to know the ones that only like English. So like English, but not the math, is the 3. So 3 is going to go in here. There is one more number that you need to include in this Venn diagram. Often when you see these, it's not on our booklet, often there's a little box that goes around those 2 circles. Because it is possible that there are people out there who don't like math or English. Remember, we had one. There is one person in that table who does not like either. One person. And that number is usually written in the bottom, it's usually the bottom right, sometimes you'll see it in the bottom left, but one of the bottom corners. That represents the people who don't like either of those things. Okay? So the numbers that you use in there are these 4 numbers here. See how I used all of those? The 8, 5, 3, and 1, they're the numbers that went into that Venn diagram. Okay, there's some more things to fill in below. The next one, it says mutually exclusive. Oop. Oh, sorry. Mutually exclusive mutually exclusive events cannot both occur at the same time. So in that diagram that I just drew, that first Venn diagram, I did have people who liked math and English. It was possible to be both, right? But mutually exclusive is in a situation where you cannot be both. And for that to happen, for a Venn diagram, it looks like this here. The 2 circles are now no longer overlapping. There's no common section to them. So it says, for example, rolling an even number and rolling an odd number. There's no numbers that are both even and odd, are they? So they are mutually exclusive events. So rolling an odd number is what we need to put in there. So if we put even numbers on this side and odd numbers on that side, there's 3 even numbers and there's 3 odd numbers. Okay? You could write down what they are if you like. So the even numbers is 2, 4, and 6 on our dice. And the odd numbers is 1, 3, and 5. No numbers that overlap. That is mutually exclusive. Okay, remember that word. Ready for the next page? Almost. So some people are still writing. Okay. So on the next page it says a survey is conducted of 50 people asking who likes coffee and who likes tea. It was found that 20 people liked both, 15 people liked coffee but not tea, and 10 people liked tea but not coffee. Whoa. Okay, so you'll get these kind of questions where it's just a whole big bombardment of information, and we need to answer some questions. First of all, it might actually be easy to skip A for a second. Let's go on to B. Let's see if we can represent the information in that Venn diagram. The 2 things that we're looking at are the people who like coffee and the people who like tea. Now, obviously, it is possible to like both of them, which is why there is an overlapping section. In the question, always keep a lookout. The most valuable piece of information to start with is if you can find that overlapping number, because it helps you work everything else out. So you always want to find the both. So let's read through it again. Of the 50 people, it was found that 20 liked both. It told me that straight away. Okay, so that's the starting number in here. 20 people liked both tea and coffee. 15 people liked coffee but not tea. So there's 15 people in here that like coffee but not tea. And 10 people who like tea but not coffee. So there's actually 30 people who like tea altogether, and there's 25 people who like coffee altogether. While I'm at it, is there an extra number that should be outside that Venn diagram? Poppy? 5. Correct. So what Poppy just did, we were told in the question that there was 50 people that were asked this survey, who likes tea and who likes coffee. My numbers that I have in there at the moment, 10 plus 20, that's 30, plus this one is 45. There's only 45 people who've got an answer in here, which means there must have been 5 people who didn't like either. Be careful how the question is worded. Okay, in the question this one said 15 people liked coffee but not tea, so I knew that 15 had to go in there. But if I word that question and say there's 25 people who like coffee, or not 25, 35, there's 35 people who like coffee, that's the total, and I had to subtract off the 20 to know that that one's 15. Okay, so we'll try to trick you, so be careful. Make sure, and one way to know is to make sure that your numbers do always add to give that 50, that total at the end. If you forget to subtract things off, usually your numbers are too big and you're wondering how on earth can this be possible? I've got too many people in here. Okay? All right, so we have some more things to answer. Let's go back to A. A said, how many people like neither tea nor coffee? We worked that out. That was the 5 people, the 5 extra people on the outside of those circles. Part C, how many people surveyed like tea? That is the whole tea circle. If they liked tea, there is 30 people. Both of those numbers together, there are 30 people who like tea. How many people like tea and coffee? Remember the word and means they have to like both. It's not one or the other. Has to be both, which is Daniel? 20. The 20, very good. And E, how many people like coffee or tea or both? Okay, so see the difference between an and means it's only this overlapping section. But if I use the words tea or coffee or both, it means it could be anything in any of those circles. It's the 45 people, just not the 5 out here that don't like either, right? So there's 45 people that like tea, coffee, or both. Daniel, you have a question?
Why is C a 30?
How many people surveyed like tea? Everything inside the tea circle is people who like tea.
Oh.
So these 20 like as coffee as well. That's what that's saying. But they still like tea, and these 10 people only like tea, not the coffee. But there's 30 people who do like tea. Timo?
I was going to say, for this, for the Venn diagram, do they need some form of title? Because if you have coffee up there, it could either mean people...
Okay, so you could say, like, if you want to be more specific, likes coffee and likes tea. There you go. Be more specific. Sure. Okay, part F. Represent, we're going in reverse of what we did last time. We want to represent what's in that Venn diagram. We want to put it into a two-way table. So, what are my headings going to be? Remember, we have tea and coffee. Yeah, Jai?
On the top, like tea and don't like tea.
Well, I did the other way around. I'm going to do the other way around. But sure, it doesn't actually matter which one you put first. I'm going to do like, because I did coffee in my first circle. So there's like coffee. Or the other option is to dislike. Remember I said they're always opposites? Dislike coffee. This one is going to have to be the tea, so it's going to be likes tea, dislikes tea. Okay, so now we want to put the numbers from our Venn diagram into there. So the first box is likes coffee, likes tea. That's the overlapping section, which is 20. likes coffee but dislikes tea. Likes coffee but not the tea means we don't want the overlapping section, we just want the 15. I'll come back to the totals at the end. Let's do the next part. Dislikes coffee and dislikes tea. Dislikes both of them. That's the one out here, that's the 5. Dislikes coffee. Sorry, that one was the 5. That was the dislikes both.
Can you zoom in?
Yeah, I was trying to see my Venn diagram at the same time. I can't see them both at the same time if I do that. Dislikes coffee, and likes tea. See, that's it. Dislikes coffee. This is my tea circle. It's the 10, correct. So that one should have been the 10. And then my disliking both was the 5. So once you have those, the 4 main numbers, remember those numbers, they're the main 4. The other numbers are all the totals where you add them up. So 20 plus 15 makes 35 people who like coffee. 10 plus 5 makes 15 people who dislike coffee. You can write, if you want a title in here, you put total. These are your totals. Going horizontally, 20 plus 10 is 30. And 15 plus 5 is 20. Either way you add those last columns, either the vertically or horizontally, both of them equal 50, which shouldn't be a surprise because there was 50 people we surveyed about tea and coffee. Okay? All right, next page. We're going to spend a couple of lessons on this topic because this is one of the biggest sections. You right, Dylan? It says it in your booklet. We finished it, yeah. So this last section here, consider the two-way table below showing the eating and sleeping preferences of different animals at the zoo. Okay? So there are animals that eat meat and there's animals that don't eat meat. There are animals that sleep during the day or animals that only sleep at night. Okay, so that's how it's breaking this down in a two-way table. Okay, we want to answer some questions. We're not putting in a Venn diagram, we're answering questions on this one. For a randomly selected animal, can it wait? For a randomly selected animal, find the probability, so P for probability, that they sleep only at night. Okay, so I'm only worried about them sleeping at night. So sleeping at night is, oops, not that pen. Let me try the highlighter. Sleeps at night is this one. And there are 68 animals that sleep only at night. Out of a total of how many? My total of all the animals that we've put in this table is 100 animals, that bottom box. So there's 68 out of the 100. Remember that we like to simplify our fractions, so you can type it in or you can do it in your head if you like, but simplify it all the way down to 17 out of 25. Okay, let's try the next question. Find the probability that the animal eats meat. Okay, so eats meat is, how many animals eat meat? 60. That's the total number of animals that eat meat. But it says or sleeps during the day. Okay, it can still count if it doesn't eat meat, but it sleeps during the day, which is the 12. Okay, remember, or can be either one of them. So that makes, our 60 plus 12 is what we want to add together over our total of 100. So that's 72 out of 100. And you would simplify that down, 72 over 100, and that equals 18 over 25. Okay. You have to be really careful when you read the questions because they can try to confuse you a little bit. Let's look at B. If an animal is selected at random and it eats meat, okay? So the animal has to eat meat, which means I'm only talking about that column there. Of the animals that eat meat, what is the probability that it sleeps during the day? 20 of those animals that eat meat sleep during the day. So the probability will be 20 out of 60. Okay, can you see the difference in that question? So of the animals that eat meat, there's 60 that eats meat, that's the total. 20 of them sleep during the day, and that simplifies to be 1/3. Let's try another one similar to that. What is the probability that an animal that sleeps during the day, okay, so that's my total, sleeps during the day, I'm talking about the 32, that's my total over there, 32 animals sleep during the day, that it does not eat meat. So no meat is the 12. So there is a total of 32 that sleep during the day. 12 of them do not eat meat. There's my probability. And I want to simplify that, of course, to be 3 out of 8. Okay, so don't think that your total is always out of 100. Could be like those ones in part B and part C.